Now let's focus on Secure Shell. In fact, version 2 of Secure Shell included with most of the Linux distros nowadays, including Redhat Enterprise 5, which is, again, the latest installment of the OpenSSH compatible protocol suite. So let's label this section OpenSSH v2 and note the myriad features included with OpenSSH v2, including, but not limited to, the fact that OpenSSH version 2 provides data encryption services based on PKI, a similar PKI implementation to what we discussed with GPG, where a unique public and related private key form a pair known as the public key infrastructure or private key pair. SSH2 emulates a similar setup, which allows SSH to be highly secure and very difficult to crack. So it provides data encryption services based on PKI, which means it ensures confidentiality of data transmissions. It's primarily concerned with the protection of the transport layer, so primarily used to protect the transport layer of your communications, which means you may use it as a tunneling mechanism to route TCP-based clear text transmissions such as Telnet and other protocols. But again, the idea is when communicating between two hosts using SSH, the transport layer is encrypted, and as a consequence you benefit from confidentiality, ensuring that eavesdropping is impossible between the two corresponding parties. Now with all of that comes encrypted shell sessions, as well as file transfers. SSH provides a facility to move files between one system and another. It also supports passwordless logins, the ability to connect to a remote system without being prompted for typical password and username authentication. It supports port forwarding, which, as mentioned, is a way to protect clear text-based communications, but can be used with other TCP-based communications. Port forwarding is also known as its pseudo, and by it we mean OpenSSH pseudo VPN functionality, in that it creates a tunnel between the two systems, the two communicating systems, that is encrypted and can be used to move data streams for various applications. Now there are myriad other features, but these are the key ones. The fact that data encryption services or confidentiality based on PKI, which means unique public and private key pairs, are used to protect sessions between communicating parties. We may also use it, SSH that is, to transfer files between two communicating parties. Now with that said, there are a series of clients that we should look at briefly before moving on to the SSH server configuration, as most users, including root level users, will primarily interact with SSH using the SSH suite of clients. An RPM query all grep case insensitive search for SSH reveals the SSH packages installed. The main package is OpenSSH. RPM queryless OpenSSH on the remote system returns the embedded files. Now this is the SUSE implementation. Let's look at the local Red Hat implementation so that we're clear. Again, an RPM query all grep case insensitive SSH will return the way it's implemented on Red Hat Enterprise 5, and as we see, the primary package again is OpenSSH. But the clients that we're going to discuss are broken out into the clients package, the server is broken out into the server package, and the general OpenSSH package contains programs that are common to all of the packages. The AskPass program is used within the GUI environment to ensure that we're able to authenticate repetitively using SSH without being prompted. So it maintains session information between the GUI interface and a remote system using SSH without reprompting us. It runs an agent which houses our credentials so that connections can be maintained. That's RPM, queryless, OpenSSH, just to discuss briefly the items that are included. There's a primary config directory beneath etc named SSH. It includes some key encryption files such as moduli. Beneath user bin, we'll find the SSH keygen utility used to generate the PKI or public key private key pair. OpenSSH directory beneath libexec contains additional items such as the key sign utility, which allows the signing of keys. Documentation and man pages for keygen and keysign. We'll be using keygen to generate a key pair for our users to be able to communicate using passwordless logins and SSH in general. That's the primary OpenSSH package, but again, there are multiple other packages including AskPass as well as clients and server. Let's take a brief look at the AskPass package using RPM, queryless, OpenSSH AskPass. And this includes GNOME as well as shell-based scripts that maintain session information regarding connectivity credentials between corresponding parties. So in other words, when you set up a session in GNOME, for example, primarily for GNOME, between your GNOME session and a remote system based on SSH, the AskPass package maintains that information so you're not constantly prompted for credential information throughout your session. Let's continue by looking at the OpenSSH clients package, which will allow us to segue into the clients that are so important. And here we see a list of useful clients, including a shared configuration file, a shared global config file. We should just note that. This is a shared global or system-wide config file for SSH clients. So there are directives in the file that all of the clients subscribe to or process, including secure copy program, which is an SCP client. So SCP, secure non-interactive copy program, which means it makes use of the SSH facility, the secure shell facility, to encrypt communications between client and server, and allows you to transfer a file from the local system to the remote system, as we've shown you throughout our studies. There's also SFTP, which is an interactive client. So again, it's secure. Everything with SSH, needless to say, is secure, but we'll list it nonetheless. So secure, interactive, FTP-like copy program, which allows you to upload and download files from a remote SSH server. S-Login, which provides login. The primary client itself, SSH. This is the shell-based client, and it functions both interactively and non-interactively. So we primarily use the SSH client to connect to a remote system interactively to gain access, a TTY, a pseudo TTY on the remote system. But SSH can be used to execute programs on a remote system without ever being assigned a pseudo TTY or a teletype terminal, a pseudo teletype terminal, or PTY. Other utilities include SSH add, which adds the credentials into our memory, the system's memory, so that we're not prompted. An agent which houses those credentials so that we're not re-prompted for authentication when communicating with remote SSH servers. SSH copy IG, an important, or copy ID that is, an important utility, an important script that is, which allows us to propagate our public key private key pairs to remote systems. So permits easy propagation of SSH pub priv key pair. So from our local system, after we've generated a key pair, this script makes it easy to copy the public key information to the remote system that we intend to communicate with. Keyscan is a utility which allows us to scan hosts for public keys, and it allows us to do so on our local as well as on remote subnets, and it automatically includes discovered public keys into our local known_hosts file, which SSH trusts or uses as its trust database when connecting to remote systems. And there are, of course, myriad documentation files, or one manual file per useful utility. But again, the key utilities include SCP, SFTP, SSH itself, SSH proper that is, as well as SSH copy ID. Another utility which doesn't show up in this package list is SSH keygen, which is used to generate the key pair. So that's SSH keygen, and it's used to generate SSH pub priv key pair, especially for use with passwordless logins. So with all that said, let's dig into the usage of each of these utilities. Again, we've used some of these utilities throughout our studies, but let's just go through them formally. So, SCP, how do we use it? We'll just expand each section. SCP followed by host 1 followed by host 2 is the general usage. Now, nestled into all of this is the specification of the source file or destination file or destination file. If we intend to copy a file from our local system, such as sample.txt, to the remote system, the usage would be as follows. SCP sample.txt, which is the source since it's located relative to our local system, to the remote system, let's say Linux CBT Media 1. By default, SCP and the other SSH utilities will attempt to authenticate to the remote system as the user who you're currently logged in as. So if this is not the desired behavior, then you'll want to prefix the remote system name with the desired username, such as Linux CBT at Linux CBT Media 1. It never hurts to explicitly indicate the username with which you'd like to authenticate to the remote system, even if you are logged in as that user. Otherwise, again, the SSH suite of utilities will simply use the name of the user you're currently logged in as. Now let's try this from the shell where sample.txt exists. And this will attempt to copy the file to the remote system. Now we made one mistake. We left off the colon at the end of the copy process. This colon tells SCP that we're finished indicating the target. Let's try that again. Otherwise, what ends up happening is a copy takes place. When you do this, you're prompted for a password, and at this point, of course, we have to indicate the right password. If we specify an incorrect password, then obviously the communications will fail. But if all goes well, we see a quick non-interactive copy followed by percentage information,